equation, in general, every time you want to try to clear fractions, it's always better if you can get rid of the fractions first step. So put this I, think of it as being over 1. And then this would be a proportion. A fraction equals a fraction. You can do the cross products. So I times that quantity needs to be in a parenthesis, NR plus R equals 1 times NE. Because we're solving for n, we're going to need to distribute this I into the parenthesis and gather our n's. We've got 2 n terms, so you want to get the n on the same side. So you can either go to the right side or the left side with the n's. It doesn't matter. I'm going to the right side. I'm going to pull this term across, making it a minus INR equals IR. Since I can't combine these n terms, I can factor an n out. You know, your goal is to get n alone. N equals everything else. And so I had to get the n pulled out of those 2 terms since I couldn't combine the terms. Factoring was the key there. All right, because that is multiplication, then you can divide by that quantity that's multiplied onto it to cancel it out. Do the same thing on this side. And there it is. N equals all this stuff. Now, it's not good enough if there's still a stray n over in the other side. It has to be n equals just everything else solved through following the steps. Checking the answer key, that is, let's see, that is the way the answer was left. Just so you know, though, if I would have decided to go to the left side with my n's, and when I made that decision to gather my n's, if I would have went the other direction, an equivalent answer to that would have been negative IR, a positive IR with a negative E. That is also correct. And the reason it's correct is if you multiply the top by a negative and the bottom through by a negative, if you do the same thing to the top and the bottom, it's still an equivalent fraction.
Why didn't we have an n in front of that E dash IR?
Right there on the bottom.
So, where are you?
Right here?
No, down below. That you divided.
I'm not sure I'm catching here.
One more.
One more. Up here?
Yeah.
Okay, so on...
See below where you got the n times E, and then on the bottom, I thought we would multiply every, because we're solving for n.
Because we're solving for n, exactly. So we want the n to stay there and be left n equals. So right, we only want to get rid of all that stuff it's multiplied by. Yes, that is what's happening. All right, other thoughts on that? All right, number 2. It says in triangle ABC, angle A is 3 times as large as angle C. The measure of angle B is 30 less than the angle of C, and then it says find the measure of the angle. So it's sort of a brain teaser question. You've got clues. But what we know is 3 angles of a triangle. All 3 angles have to add up to be 180. So if I can represent these 3 angles with an X, then I can add them to equal 180. All right, so what we know, we've got A, B, and C, and here are the clues. A is 3 times C. B is 30 less than C. So C minus 30. A is 3 times as large as C, and then we'll just call C, C. We'll refer to it as our basic unknown. So these 3 angles, C will just call itself and let it be the basic unknown. A can be referred to as 3C, and B can be referred to as 30 less than C. So it's nice that the clues all lined up so they all refer back to C, because now I just have one variable. Those 3 angles, angle A plus angle B plus angle C, have to add up to be 180 degrees. And then we're able to solve this. That's 5 C's minus 30. Throw the 30 across. Adding 30 then gives me 210. Divide by 5. And then check 210 divided by 5 for me. So about 42. Is it 42? All right, so angle C then itself is 42 degrees. And it asks for all 3 angles. So angle B would be 42 minus 30. That's 12 degrees. And then angle A is 3 times C. 3 times 42, let's see, what is that, 126. So those three angles should add up to make the 180. In order, I suppose, the A, B, C. So 126, 12, and 42, answer D. All right, questions on that? Because A was 3 times the C value. Once we got C is 42, it's 3 times 42. Does everybody have a study guide? I've got a few extras if anybody needs one. Y'all need one.
Okay, how did you get the 126 and the 12 again?
After you get C is 42, then these are have C's with them. So 42 minus 30 and 3 times 42.
Where did that 84 come from? Like on the answer? Like I get the 126 and the 12. I get where the 126 and the 12 come from. Like I get that, but where is okay, well, where does that come from?
The top one is A is 3C. So 3 times 42. Once you get C is 42, A is 3 times, sorry for the string, 3 times 42. Anybody else need a study guide? Then it's another hand. All right, number 3. The chemistry question where we're doing percents. We're trying to do a mixture problem here and getting a certain percent mixture at the end. So we've got something here plus something. These 2 containers are going to be poured into the 3rd container for our output here. So it tells me that what I have on hand is 3 liters, that's 4%. 3 liters is the amount, 4% is its concentration, and this is a silver iodide concentration. It's mixed with, so plus, in this container, it doesn't tell me how much. So that's my unknown X. It is 10% concentrated, and I'm trying to get my end result over here is supposed to be 6%. Now this is probably the hardest part to make sure you remember these, especially if you haven't done them in a while, is you can't have just a hanging percent. It can't be 6% of nothing there. It has to be 6% of a base. And the base is these 2 amounts are added together when we pour them here. So it's 3 plus X. And then that completes our balance that we need. Then we multiply 4% of 3, so you multiply what's in your boxes. 4% of the 3 liters plus 10% of the unknown amount to equal 6% of the combination 3 plus X. And then you would solve that equation to save a little time to get through the setup. I'm going to let the solving that equation go.
What time is tomorrow's class at 11 a.m.?
12:30.
12:30.
Yeah, and right, if you can come in later, come on in later. At any time you can walk on in, I'll leave the door open for you. That helps.
I'll work at tomorrow at 12:15.
Okay, number 4.
Are you not going to finish that one?
Okay, number 4, Roberto. It's almost similar to this. We're going to mix money this time. We've got 2 accounts. Money, we'll think of these as money bags. We're going to combine to equal a total on the end. So Roberto is investing some money at 7%, so the amount sum is unknown. 7% is his interest rate. Then in the other account, it's going to be $2,000 more than twice. Okay, so that is known, but it's a little bit of a jumble. $2,000 more than twice would be 2x plus 2,000. That's the amount, and that's at 10%. And we're trying to get a total over here on our output of $2,900. Notice that it doesn't have a hanging percent. It already is in interest form. It's been multiplied together, and so that does not need 2 parts like this hanging percent we had earlier. So we have 7% of X plus 10% of the 2X plus 2,000 to get $2,900 in interest. So it's like you've got the amount of interest in this account is its principal times rate times time is a year, understood here. So principal times rate gives us the interest out of that account, plus the principal times the rate gives us the interest out of that account. So interest plus interest needs to equal a total of $2,900 in interest. So that would give us a solvable equation. You know, and I should have mentioned it maybe on that last problem too, a strategy that sometimes you can use, you don't have to, is to clear your decimals. If you don't want to distribute a decimal, or it's true with a fraction too, anytime you want to simplify your equation, you know, feel free to do that. You can do anything you want to an equation if you do it to both sides. So it would be perfectly acceptable and maybe make it easier if you times both sides by 100. You'd have to do both sides if you decided to do this. But times it by 100, what it does is it moves these decimals over that amount of places. Times it by 100 moves it 2 places. It makes it a nice 7x. It moves this 2 places, makes it a 10. You don't need to bother the parentheses. It will be distributed and affected in a minute. And then you have to, even though this doesn't show a decimal, it's at the end, you have to times it also by 100. So it adds 2 zeros to that. And then it's probably easier. You're probably less likely to make a mistake if you do that first. Again, optional, but helpful, I think. And then distribute and solve, again, to save time. You know what? I'm actually going to finish this one, and I have a reason I want to tell you something about this one to remind you of something when you're taking the test. So let me go ahead and distribute and solve. If I get too many zeros, that's fine. So combining your x's, I've got 27 x's. Throw the 20,000 across the line. Okay, then divide by 27, and that will be, what, 10,000. All right, so what I wanted to really warn you about on this, whenever you're taking a multiple choice test especially, now on this number 4, 10,000 isn't even an option, so you wouldn't have any confusion there. You'd know, oh, there's something else I need to do. But X's 10,000 is not a choice. And the reason I wanted to finish this one to remind you, always read what they ask you for. This question says how much was invested at 10%. Now because I let X be my 7% amount, this is the amount invested at 7%. It's a good answer, but it's just they want to know how much is invested at 10%. So do make a note to yourself. Make sure you answer the question as asked. Do any follow-up steps. Probably a lot of the problems that we've done, the biggest majority, 80-90% of the problems, whenever you get X, you're done and you say, okay, that's the answer. But there are those questions where they ask you further, a follow-up question. And here the question is how much at 10%? So that's 2X plus 2,000, right? So we need to do 2 times this 10,000 we found for X. That's 20,000 plus 2,000. So 2X plus 2,000, when we solve that, makes it 22,000 for our final answer. And that's the answer we're looking for, answer B, 22,000. This came from, because I did the times in by 100, you may not have. You should have got the same result though. Either way, you should have got the 10,000 with the decimals or not. Yeah, the answer should still come out the same. Right. Okay. Number 5. All right, now number 5, you want to clean up this imaginary complex number. You cannot leave imaginaries or radicals for that sake matter. You can't leave those in the denominator. So the trick to get rid of a binomial in the denominator is to times it by its conjugate. So you times that by 5 minus 3i. So timesing top and bottom by 5 minus 3i has to be FOILed, numerator and denominator. So the first, and so on. FOIL the denominator. And then combine any like terms. So we've got a negative 24i and a negative 30i that will combine to be negative 54i. And then because there's an I squared, anytime you have an I squared, and make a note to yourself, I squared is negative 1. If you're kind of thinking about this note card, I said I'd try to say, make a little list of what I think I would put on my card. If that's something that you think you need a memory jog for, maybe do that. Or if you need to remember the times by the conjugate. So as we go through, maybe make yourself a little side note. Here's what I think I will need that'll clue me in to do this. And maybe remind yourself to follow up on reading problems. I would remind myself of that. I think I'd put that on my note card because that's something you might forget to do. Follow up and answer the question that's asked. So I'll try to remember to write things here as I think of them, and then you might condense it down more or add more to it. Yeah, it's a little too small, isn't it? Okay. Just a little bit. I guess I was thinking when you write on a note card, you squeeze it in, maybe write small. Okay, so follow up, or however that you would remember that thought to check your answers and make sure it works back in the problem. So I squared is negative 1, so an 18 times a negative 1 will make that turn into a negative 18. It always changes the sign of your term. So this is now a negative 18 and a positive 40, which is 22. Negative 24i, negative 30i is negative 54i. So combining your like terms, in the bottom, you've got same thing happening that makes it a plus 9. So 25 plus 9 is 34, and then the 15i's cancel out. So then you can reduce this. In imaginaries, they want it reduced. You always pull the real and the imaginary part separate. So 22 over 34 is the real part, and then 54 is also divided by 34 with the I. This will reduce to 11/17, and oh, that's 54, sorry. And then this reduces to 27 over 17. You know, both of those are even, so you can have that for your final answer. Okay, questions on that? Do you all need to move around maybe? Do you think that would? Where's Aaron, by the way? If you all need to move up or around though to see better, that's fine. Okay, questions?
We're 21.
Oh,
Anything after the second?
this, are you asking about the 34 or the, what did you say, 34? The 34 came from the negative 9i squared changed to a positive 9 because I squared is negative 1. It changes its sign, so it's plus 9. And then 25, those add together, and that's where the 34 came from. Does that help you with any?
Yeah.
On anything? Okay, other thoughts?
Oh, wait. There's more. Yeah, of course.
Yeah, there's always more, right? It's always lots of steps.